Hmm. Hello, or is it audible? Hello, hello, hello.
Yes, sir, it's yes, sir.
Right, no, no. Hello, is it audible, right? అరే లైట్ ఎక్కువ వస్తుందా ఓకే ఉందా నార్మల్ ఉందా హలో హలో ఓకే ఉందా ఎక్కువ అనిపిస్తుందా రైట్ సో వీ వర్ డిస్కసింగ్ alkanes right now last class. So alkanes from hydrogenation, right? So from alkenes, hydrogen in presence of nickel, platinum, palladium, you get alkanes, right, from alkynes. So sometimes they'll ask the question is like this. So 1 mole of hydrogen, presence of nickel, platinum, palladium. So which double bond is converting into alkane? Come on, let me know. Which double bond is converting into alkane? మీరేనా So which alkene? So what is the difference between two alkenes here? What is the difference between two alkenes? Hmm? Hello? Madam. ఉంది మేడం స్టార్ట్ అయిందిగా లేదు లేదు జాయిన్ అవ్వమనండి మళ్ళీ ఏం లేదు ఏం నెంబర్ కొడుతుంది 9704199992 అవునవును ఇప్పుడే స్టార్ట్ అయింది నా సైడ్ ఏం లేదు మేడం, వేరే డివైస్ నుంచి ఏమైనా ట్రై చేయండి లేకపోతే. Right now. So which alkene is more stable here? Which alkene? Two types of alkenes are here. Which alkene is more stable? Hmm? Which alkene is more stable? Hamsini?
Yes, sir.
Which alkene is more stable? This yellow one or this green one? Which alkene is more stable?
Yellow one.
Yellow one is more stable because more substituted, more number of alpha hydrogens. It is how many alpha hydrogens? 2, 3, 2. Total 7. But in this case, only 3, 1, 4. Right? More stable means less reactive, of course. So this is the product which we will get. So this double bond, 1 mole of hydrogen if you are using, this is the way which we need to do. Okay? Write it down. More stable alkene is less reactive. And last class we discussed from decarboxylation, we discussed Clemmensen reagent, Wolff-Christian reagent, right? And so from Grignol reagent, from Grignol reagent, Grignol reagent. So what is Grignol reagent? So what is the use of Grignol reagent? Let me know. Come on, Krishna. Halogenation. Come on. What is a Grignol reagent? RMGX. RMGX. What is R? Alkyl group. So the speciality of this Grignol reagent, organometallic compound. Organometallic compounds means what? When the carbon is attached to any metal, like RLI, RMG, right? CLI, right? CMG, like that. So it is C minus Li plus C minus Mg plus, like that, right? For example, if carbon is attached with more electronegative atoms like chlorine or anything, so it is C will get positive charge, chlorine will get the negative charge. But whereas in this case, C will get negative charge. So particularly RMGX, Nana, R minus MgX plus. R minus MgX plus. What is R? What is R? Alkyl group. Either it could be methyl, ethyl, propyl, isopropyl, whatever it may be. So Mg, X means generally we can take chlorine or bromine or iodine, like that. Halogen, RMgX. So in the preparation of alkanes, RMgX plays a vital role. So generally RMGX with any proton donor, Nana. RMGX plus any proton donor. Any proton donor will get R minus is coming over here. It is from H plus, proton nothing but H plus. Why we will say H plus is a proton? It doesn't have any electrons and it doesn't have any neutrons also. Only one proton is there, that's why we could say proton. So RMGX plus any proton will get alkane. Alkane, R and H. RH, RH we will get. RH we will get. జాయిన్ అవ్వట్లేదండి. Then what are proton donors, Nana? What are proton donors? Proton donors. Is water is a proton donor? Water, H plus. For example, acetylene. CH3, C triple bond, CH. The hydrogen is directly attached with triple bond carbon. This is having acidic nature. This is also acidic nature. But these three hydrogens, we can't, those are not acidic hydrogens, right? Because those hydrogens are directly attached with the carbon. Because this carbon is what? More electronegative. These hydrogens, write it down. The hydrogens which are directly attached to the triple bond carbon. Triple bond carbon. This is sp hybridization. Sp. So percentage of S character is directly proportional to electronegativity. So in this case 50% S character is there. 50% S character. 50% S character. For example, CH3, C triple bond C CH3. In this case, is it possible? Is it having any protons? Proton donor? No. This total molecule doesn't contain the proton. Water, acetylene. Okay. Next. Alcohols. H. Either methanol, ethanol, any alcohol will have the, for example, CH3, OH, CH3, methanol, ethanol, propanol, whatever it may be, even including phenol. Phenol is also proton donor. Next, this is alcohols, phenols, carboxylic acids, or COOH, like HCOOH, CH3COOH, including benzoic acid. Benzoic acid. benzoic acid, amines, RNH2. Even secondary amines also is having the tertiary amines doesn't have the hydrogen, so primary amines we can take like methanamine, ethanamine. Anything like this, methanamine, ethanamine. Even we can take D2O, deuterium oxide. Deuterium oxide. We can take pyridine. The hydrogens are attached to the more electronegative atoms. Those are generally proton donors. No? Proton donors. Proton donors. Attached with more electronegative carbon. So anything with RMGX, we will get alkanes. With aldehydes, ketones will get different types of compounds, means we'll get alcohols, but that we will discuss in nucleophilic addition reactions, but not needed. Then హలో, అది వేరే డివైస్ నుంచి జాయిన్ అవ్వండి మేడం. ఏదైనా వస్తుంది. అయితే యూట్యూబ్ డైరెక్ట్ జాయిన్ అవ్వకుండా కూడా చూడొచ్చు. చూడండి ఒక్క రోజుకి. పర్లేదు. సరే అయితే ప్రాబ్లం ఏందో మరి. సరేనా? So all are proton donors. Now the question is CH3 MgBr plus water, right? So water is the proton donor, right? H plus. So generally this undergoes H plus plus OH minus. Simply no. So here is CH3 minus is coming over here. CH3 minus MgBr plus CH3 minus this H plus CH4. So directly I am writing to avoid the confusion. CH3, this yellow hydrogen is coming from over here, right? CH3 minus CH3H, nothing but simply we can write CH4, methane we will get the preparation. And remaining what is the byproduct? MgBr and this OH minus plus MgBr OH, or sometimes you can write like this, Mg, right, OH, Br also will write like. The byproduct is not that much of important. The preparation of alkane is important here, right? Hello. So now try these products. హలో. క్లాస్ అవుతుంది 7:38కి అయిపోతుంది. ఇప్పుడే స్టార్ట్ అయింది. సరే. సరేనా? యాసిడ్ బేస్ H ప్లస్. So I gave you this one, right? Any proton donor we can use. Okay. So first write some more questions here. Like this. Write these questions. Easy only. Generally, we'll get alkanes directly. వైట్ షర్ట్ రిఫ్లెక్షన్ వస్తుంది కదా దీంట్లో. బ్లాక్ టీ షర్ట్ వేసుకో. డనా? Completed everyone? Hello. Then, so in this case, ethane, CH3, CH3, and byproduct is no need. Actually, if you want, you can write the product CH3C, CH3, CH triple bond C, Mg, Br, minus plus like that. In this case also, ethane, the byproduct is no need. Actually, if you want, you can write here. In this case, no, it is the deuterium is coming. In this case, benzene, H is coming, benzene. In this case also, benzene. In this case, ethane. In this case, propane. 1, 2, 3. Okay, now? Any doubts, anybody? Here, no? Ethane, ethane, ethane. In all the cases, ethane. Ethane, ethane, ethane. Then, next, no? Coal-based electrolysis. This is important, no? Coal-based electrolysis. Actually, in second year, we'll discuss this electrochemistry, electrolysis. So in electrolysis, two types of cells are there: electrolytic cells and electrochemical cells. No? So particularly, for example, try to understand in electrolytic cell, anode and cathode is there. They are passing. Electrolytic cell here is electrolytic cell. Electrolytic cell. So for total electrochemistry, I would say NOx, red cat. What is NOx, red cat? At anode, oxidation reaction takes place. At cathode, reduction. Write it down. Anode. At anode, oxidation. At cathode, reduction. At anode, oxidation, cathode, reduction. What is oxidation? What is oxidation? Oxidation, reduction. Addition of oxygen, removal of hydrogens, removal of electrons. Write it down. Addition of oxygen, or we could say removal of hydrogen or removal of electrons. Reduction is opposite. Removal of oxygen, addition of hydrogen or addition of electron. Imagine, for example, sodium gives rise to Na plus electron. Oxidation or reduction? Removal of electron. Nothing but what? Oxidation. For example, Cu2 plus 2 electrons gives rise to Cu. Addition of electrons. What is this? Reduction. For example, Zn gives rise to Zn2 plus 2 electrons. What is this? Oxidation. write it down. Oxidation, reduction, right? Anode, cathode. In this case, now imagine electrolytic cell anode and cathode. Anode generally we could say positive charge nana here. Cathode is negative charge. But whereas in electrochemical cell in second year opposite, but I'm not discussing that. So to understand the coal-based electrolysis, so we should know what is anodic reaction, we should know what is cathodic reaction. At anode, oxidation takes place. At cathode, reduction takes place. What is oxidation? Oxidation means removal of electrons, right? Cathode means addition of electrons. So first we need to have this basic idea to understand the coal-based electrolysis. Write it down. Done? Completed? Hello? Oxidation, oxidation, reduction, cathode, anode, anodic reactions, right? For example, first fused NaCl is there, imagine. Imagine this is anode, cathode. Okay, I told you. Anode means what? Positive charge, cathode means negative charge. So NaCl is there in the solution, Na plus Cl minus. At anode, which reactions are takes place? Let me know. At anode, right? Oxidation. So oxidation means which one is coming here is Na plus or Cl minus, positive charge. At anode, Na plus or Cl minus, opposite charge will attract, obviously, right? Cl minus. So 2 moles of Cl minus, Cl2 plus 2 electrons. Removal of electrons takes place. This is at anode, oxidation reaction takes place. At cathode, negative charge, right? Na plus electron gives rise to Na, like this. Reduction reaction takes place. This is exactly electrolysis. Fused NaCl when we are taking. Fused NaCl. So just write it down. In aqueous NaCl, somewhat different products we will get. So preferential discharge potential theory. So that we will discuss in electrochemistry. So not here. Okay. So but first we need to have what is anode, what is cathode, what is oxidation, what is reduction. The problem with the 11th class guys, they don't know all this anode and cathode, oxidation, reduction, right? Anode is having the positive charge, cathode is having a negative charge. So but we'll explain the coal-based electrolysis. At anode we'll get these products and cathode will get these products, means it's biscuit. Biscuit means could not get anything, right? वो पड़ गया, हम सीख लिया, गया। चलो, so now we'll start original coal based electrolysis. At anode, which reactions? Oxidation. At cathode, reduction, anode positive and cathode negative. So this is the basic thing. Now coming to the original reaction, original coal based electrolysis. Anybody is didn't, right? You can take the screenshots. Chalo. 2 moles of RCOO Na, or OK also we can take, plus 2 moles of water. What we are doing? What we are doing? Electrolysis. Electrolysis. We'll get RR plus CO2. These are at anode, no? At anode. And plus NaOH, 2 moles of NaOH plus hydrogen at cathode. At cathode. At cathode. Alkane. Actually, why we are doing this coal based electrolysis? To prepare alkane, right? RR. In this method, we can't prepare methane because 2 R's or RR is forming, right? We can't clap with one hand, can we? Same thing. So this actually at anode which products are forming, at cathode which products are forming. So generally they are asking, but how they are coming? So we'll understand the mechanism. What is the mechanism? So first RCOO Na, 2 moles if I am taking, RCOO minus 2 moles plus 2 Na plus. 2 ions are like Na plus Cl minus, same like that. So now we will discuss at anode which reaction takes place. At anode reactions are important. Anode is which charge? Positive charge. At anode which reaction takes place, Nana? Hello? Oxidation. At anode, oxidation reaction takes place. So RCOO minus Na plus, which one is coming to anode? RCOO minus. RCOO minus is undergoes RCOO electron plus 1 electron is going out. Minus means 2 electrons, right? So that is undergoes homolytic cleavage, 1 electron is going out. If I am taking the 2 moles, no? 2 electrons are going out. This is called what? Oxidation, removal of electrons. But here one more important thing, this one, RC double bond O radical. Can we write like this? This one? Hello? So this here is homolytic cleavage takes place, Nana. Homolytic cleavage. Homolytic cleavage means what? Equal cleavage. We are taking the 2 moles right here. 2 moles. So what we will get? R radical plus 1 more R radical. RR is forming. And C double bond O radical. Here is 1 more radical is coming from here. They are forming a bond, nothing but what? This is CO2 is forming. CO2. 2 moles, if you are taking 2 moles of CO2, we will get 2 moles of CO2. So this is a mechanism for a anodic reaction. Write it down, everyone. If anybody confusing here, I'll explain once again if you want. So actually, Rana, so this one R C double bond O minus, right? This one. Can we write like this? The structure.
Yes, sir.
So minus means what? 2 electrons, right? 2 electrons here. So undergoes homolytic cleavage like R C double bond O radical plus electron is going out. Like 2 moles if you are taking, 2 molecules we are getting, right? Hello, 2, right? And 2 electrons are going out. This is the first step. Is it clear? And the second step, Nana, this molecule R C double bond O radical here is undergoes homolytic cleavage here between R and C. R and C. It is homolytic cleavage. So means what we will get? Here is R radical plus C double bond O radical, and here is one more radical is right there. We just break the bond is like this. So 2 moles, right? 2 moles. This is also 2 moles.
Yes, sir.
2 R radicals. R radical plus one more R radical. RR. Okay. Then this radical, this is forming a CO2. So these are all takes place at what, Nana? Where? At anode. At anode, RR plus CO2 is forming, right? RR means alkane, CO2 means carbon dioxide. Clear?
Yes.
So, at anode, positive charge oxidation, I already explained here, right? To avoid the confusion, right? So this is the basic information to understand this reaction actually. And the advantage of this reaction, once again we can prepare this reaction coming in alkene and alkyne also. Same mechanism, but just a slight changes takes place. Same oxidation, same electrons are going out. So first we need to know what is oxidation, what is anode, what exactly happened and all. If you don't know that, chalo. Clear? Completed? Now, at cathode what happens? Here only I'll explain, because if I'm changing the page, at cathode. At cathode is which charge? Negative charge. At cathode which reactions are takes place? Reduction. Reduction means what? Addition of electrons. Reduction means, if you want you can write addition of electrons. So which one is remaining over there? Hello, which one is remaining? 2 electrons we are adding to water, 2 moles of water, we'll get 2 OH minus plus hydrogen gas. This 2 OH minus will react with 2 Na plus 2 Na plus akkada undi kada, you get 2 NaOH. So at cathode which products are forming? Hydrogen as well as NaOH. 2 moles of NaOH and hydrogen at cathodic reaction. Cathodic reaction is not that much of important, but write it down, right? Anodic and cathodic, what exactly happening? This is a clear-cut mechanism. Then, hello. Hello. Now, time to write the products. EH3 2ONA plus water electrolysis. So take 2 moles. Of course, sometimes they won't give the 2 moles. We need to consider by seeing the equation. We need to understand. Sir, they didn't give the 2 moles, so I don't write the products means. क्या हो जाएगा? And after completing these products, you will get to know that come on, write the 1, 2, 3, 4. Right or wrong doesn't matter, Anna. Just write it down. I'll explain the products. Done? Completed? ఈ లైట్ కొంచెం వామ్ ఉంది కదా, కొంచెం అంటే తెల్లగా కనిపించారు. డిఫరెంట్ మంచిగా ఉంది కదా ఇదే లైట్. బాగా తెల్లగా అయిపోయినాయి. వామ్ లైట్ అంటారు. కృష్ణ, కృష్ణ,
Yes, sir.
రాసావా ప్రొడక్ట్స్?
Yes, sir.
వాట్ ఈస్ ద ఫస్ట్ వన్?
Sir.
Ethane. CH3 remaining byproducts are same, bro. CO2, NaOH and hydrogen. You can see one pattern over here. What is the pattern which we can understand? What is the pattern? What if you can see the products, 3 products, we can understand one thing. What is that? Mirror image, okay. Plane of symmetry, symmetrical alkanes. Alkanes, even number of alkanes generally we will get. Even number of alkanes means this reaction useful for symmetrical, the preparation of symmetrical alkanes. Note it down. Whole base electrolysis is useful for preparation of symmetrical alkanes or even number of alkanes. Even number of alkanes. This one, this particular portion, 3 carbons are there, double. This is double. This is double. The COH is going out. In this case, just cut here. So I need the reactant here. Krishna, what is the reactant? Lot of people, 99%, 90% of students will do the mistake here. 100%. Let me know. It's this name, carboxylic acid. Manlo, you can consider as a carboxylic acid. Let me know the product. Tell me the name of the reactant. They'll give the options like this. 2-methyl propanoic acid, 2-methyl sodium propanoate, 2-methyl sodium propanoate, 3-methyl sodium butanoate, option C, 3-methyl sodium propanoate. What is the answer? Right? 1, 2, 3, 4. 3-methyl sodium butanoate. So there is a huge chance to do this mistake. Which mistake? 2-methyl sodium propionate seems to be right answer. 99% of students will do the silly mistakes here. So put 5 star. And one more important thing, in this reaction we cannot prepare methane. Note it down. In this reaction we cannot prepare methane. Why? Symmetrical. Same Nana, completed. Any doubts? So the alkenes, this reaction once again is going to come in the alkenes chapter as well as the alkynes. The same reaction. Here only I am trying to explain this. Same method, same, everything would be same. CH2, COO, succinic acid. CH2COOH, sodium succinate. Na. We know O my such good appeal, right? Oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid. But in this particular case, we will take succinate, sodium succinic acid, and then sodium succinate, and 2 moles of water, electrolysis. Product, what is the product we will get here? Alkene, CH2 double bond CH2 plus 2 moles of CO2 plus 2 moles of NaOH plus hydrogen. These are at anode, these are at cathode. So I want to make it somewhat colorful. Because life is beautiful, right? Enduku single colors rayali. When we have the option, we have to utilize, right? Otherwise black and white. So mechanism. Hello. Krishna, which color seems to be good enough? What means visual? Hello.
White Two producer.
So white, green, yellow. Okay. Right? The first step now. At anode reaction, same. At anode. Anode. Which charge now? Positive charge. Which reaction is takes place? Oxidation. So now we will take this ion. Right? Anode. First, which reaction is takes place? Oxidation. So same like that. 2 moles they are just taking. CH2, CH2, COO. So I'm just writing radical. COO, O radical, C double bond O radical, plus 2 electrons. Next, here only I'm writing that homolytic cleavage is takes place here, no? Right, CH2, CH2. Here one radical, here is one radical. Two radicals. I'm writing as a double bond plus 2 moles of CO2 is going out. So these bonds are when we are combining, we'll get ethene. Ethene plus CO2. So at cathode reaction would be same. Hello, cathodic reaction. At cathode negative, reduction is takes place. So 2 electrons plus 2 moles of water will get 2 OH minus plus hydrogen and 2 OH minus plus 2 Na plus, which is coming from the here, get 2 moles of NaOH. Write it down. Don't by heart, try to understand. ఈరోజు ఇద్దరు సబ్స్క్రైబర్స్ పెరిగారు. నాట్స్ ఇస్తామంటే పెరుగుతున్నారు వాళ్ళే. మానిటైజేషన్ అవసరం లేదు మనకి. సబ్స్క్రైబర్స్ పాపం చూస్తే చాలు. So write one more important point. So in case of previous case and also, so methyl groups now, percentage of field primary, secondary, tertiary. Percent of field means methyl group. In the methyl group, alkyl group is methyl group. So more than primary alkyl, secondary and tertiary alkanes, like radical free radicals like For example, CH3 radical, radical, right? These are the also primary, like this is secondary. In case of tertiary, so we'll get alkenes, major products. CH3, CH3, CH3. In this case, alkenes as a major product. Alkenes. Percent of yield analysis. Percent of yield. Percent of yield like this. And one more important thing, we can prepare alkynes also same method. How? We are already starting where sodium malate we will take, right? Double bond. So one more double bond, triple bond is coming. Same method. Okay, that do as a homework for you guys. Same as it is. Just so we'll do one thing. CH double bond CH COO Na COO Na plus water electrolysis. So what we will get? CH triple bond CH plus CO2 NaOH hydrogen. Same, Nana. Same. At cathode, at anode, at cathode. Same mechanism. If you want, you can write it down. I think you can write, right? Mechanism. Yeah. Chandra. So for example, the reaction is like this: CH2 taken 6 COONA COONA COONA. In this case, what exactly happens? Hello. Electrolysis. Here is radical, here is radical. So because it's a big ring, 6, right? Directly can write the cyclohexane. Cyclohexane, remaining products are same now. Remaining products are same. Sorry, H2. H2. Done, Anna? Hello. So yesterday I discussed that coal base, the decarboxylation, right? Ram? In case of decarboxylation, I explained COO Na plus what, Ram? Hello. NaOH plus CaO. Will get RH plus Na2CO3 something. So here mechanism is also important here. For example, we are taking the carboxylic acid RC double bond O OH plus NaOH. So mechanism, because they are asking some questions based on mechanism in decarboxylation. Or C double bond O minus plus water is going out, no? Plus, right, Na plus, right, like that. In the second step, R C double bond, this is slow step, Nana. Slow step. So slow step means what? What is slow step? Rate determining step. This is coming over here now, so R minus is going on like this. We'll get here is CO2 plus R minus. This R minus plus H2O, RH, alkanes plus OH minus is going out. Particularly here, what is the intermediate we are getting? What is the intermediate? Carbene ion. Carbene ion is more stabilized by which one? Minus M, minus H, minus I, neutral molecule. So then plus I, plus H, plus M. Like that. So they are asking the question, which of the following is so faster in decarboxylation? Right? Option A, write the question. Which of the following is faster in the decarboxylation? Faster in the decarboxylation. So the following is faster in the decarboxylation. What is the answer? What is the answer here? Here. B. Okay. Any other answers? We'll get the negative charge here. Negative charge, more electronegative, right? So which is more electronegative? Inductive effect. AB, CD. More electronegative, right? Carbene ion is more stabilized by the more electronegative. Fluorine is more electronegative than chlorine. Bromine, iodine. In this case 2, in this case B. Okay? Hello. Here write one more question for this one. Two moles if you are taking, what exactly the product we will get? Radical, two benzene radical rings are clubbing like that. So what we discussed today? Hmm? Hmm. So alkenes which are more stable alkenes, so less reactive. So when sometimes if they are asking the question, so we need to write this one. Then Grignard reagent, I told you, RMGX. So it is any proton donor. These are the proton donors which I gave you. So different types of proton donors. Not only this, even we can take sulfuric acid. It's whatever the proton donors are there. So those donors, and I told you the mechanisms. Then coal-based electrolysis, one of the important reaction today. In coal-based electrolysis, first what is anode, what is cathode, what is oxidation, what is reduction, what is electrolytic cell, what is electrochemical cell. Electrolytic cell means what, no? So electrical energy we are using, we are producing the chemical energy, right? Electrolysis. So then these mechanisms which we discussed today, right? And those things. Okay. Tomorrow Wurz reaction is there, and because these are the preparation, I'm just going bit slow by intentionally. I can give you directly the reaction and products, but you are going to by heart those reactions. To avoid the by heart, so I'm just going bit slow because initially it seems to, because you are very new for preparations of these organic reactions, right? So that's the reason I'm just going bit slow. Otherwise, if you would be the second year students, I'll go bit faster mode. So anyway, so just revise it, and I will continue tomorrow. Thank you.